In this lesson, we're going to go over Unit 6, Acquisition 1 on two-step conversions. So first, just a very quick review from our last video. We talked about two different types of conversions. So first, let's say you are converting from either moles to grams or grams back to moles. So double-sided arrow, we can go either way. If you're given moles and solving for grams, or if you're given grams and solving for moles. The conversion factor is the molar mass that we calculate using our periodic table. We also talked about how to convert between moles and particles. And again, particles is just like a general term, usually for like atoms, ions, molecules. If we're converting between moles and particles, our conversion factor is Avogadro's number. 1 mole is equal to 6.022 times 10 to the 23rd. So what we're doing now is we're going to do two-step problems. So instead of converting from grams to moles, we might convert from grams to moles to atoms. First example. How many grams of NaCl are in 2.4 times 10 to the 23rd molecules of sodium chloride? So whether it's one step, two step, three step, we're going to follow the same steps. Let's look at what we're given and look at what we're solving for. I'm given molecules and we're solving for grams. Look at our arrows. There is no way to convert directly from molecules to grams. If I'm starting with molecules, the only thing I can do is use Avogadro's number to convert to moles. So that is going to be step 1. Always start with the given. (2.4) times 10 to the 23rd molecules. If I'm starting with molecules, like I said, the only thing we can do is use Avogadro's number to convert to moles. Think about where your units go in order for them to cancel. If I'm starting with molecules and I need molecules to cancel, it has to go in the denominator. 6.022 times 10 to the 23rd molecules in every 1 mole. Molecules divided by molecules will cancel. If I were to stop and solve this problem, this would give me moles, but I don't want the number of moles, I want the number of grams. So I'm going to add a second step. Again, think about where your units go to cancel. If I have moles in the numerator, I need moles to go in the denominator so it cancels. I'm at moles and I'm solving for grams. If I'm converting between moles and grams, I need the molar mass. So we can look up sodium on the periodic table, 22.99, chlorine, 35.45, which gives me a molar mass of 58.44 grams per mole. So in 1 mole of sodium chloride, I have 58.44 grams. Now if we set this up right, moles divided by moles will cancel. We're left with grams, and that's what we were solving for. So lastly, let's put this in our calculator and solve. Anything across the top multiplies. So 2.4 times 10 to the 23rd times 1 times 58.44. And then we're going to divide by anything on the bottom. Divided by 6.022, E23, and I get 23.2906, a whole bunch of decimal numbers that we're not going to need because we're going to round to significant figures. Sig figs are always going to be based on the given. My given has 2 sig figs. My answer has 2 sig figs, so I round this to 23, and my units are grams. So final answer, 23 grams of sodium chloride. Let's try another. How many NaOH molecules are in 37 grams of sodium hydroxide? Molar mass of sodium hydroxide is an even 40 grams per mole. So how many sodium hydroxide molecules are in 37 grams of sodium hydroxide? We're always going to start with the given. Given is 37 grams. I'm solving for molecules. Again, there's no arrow, there's no conversion to get you from grams to molecules. If you're starting with grams, the only thing you can do is convert to moles, and the way we do that is by plugging in the molar mass. Always set up your units so they cancel. So if I start with grams, grams are going to go in the denominator. Grams divided by grams cancel. There are 40 grams in every 1 mole of sodium hydroxide. Next, we can't stop here. A mole is not the same thing as molecules. So now if I'm converting from moles to molecules, I need Avogadro's number. Always setting up our units to cancel. In 1 mole, there is 6.022 times 10 to the 23rd molecules. Grams divided by grams cancel. Moles divided by moles cancel. And we're left with molecules, which is what we're solving for. Alright, so we are going to multiply across the top. 37 times 1 times 6.022, E23. And then divide by whatever is on the bottom. 40 times 1 is just 40. So I'm going to divide my answer by 40. And I get 5.570 times 10 to the 23rd. Doesn't matter how many decimal places you write initially because we're always going to round it to the correct number of significant figures. The given has 2 sig figs. My answer has 2 sig figs. I'm going to round this to 5.6 times 10 to the 23rd and bring down my units. molecules. Let's do one more problem like this, and then I want to show you a new type of problem. If you're ready to try this one on your own, after you write down the question, pause the video, try it on your own, and then come back and see how you did. How many grams of carbon are in 5.32 times 10 to the 23rd atoms of carbon? All right, always, always, always start with the given. 5.32 times 10 to the 23rd atoms. When we're setting up our conversion factors, we're always going to set up so our units cancel. So if I start with atoms, I'm going to need atoms to divide by atoms in order for it to cancel out. And there are 6.022 times 10 to the 23rd atoms in every 1 mole. Atoms divided by atoms cancel. If we stopped here and solved, that would tell us how many moles we have. But I want to know how many grams we have. So if I am now at moles and I need grams, my conversion factor is molar mass. We can look up carbon on the periodic table. Its molar mass is 12.01 grams in every 1 mole. Now, moles divided by moles cancel, and I'm left over with grams, which is what we were solving for, so that's great. Last step would be to solve. So again, multiply across the top, 5.32 times 10 to the 23rd times 1 times 12.01. And then we are going to divide by what's on the bottom. And I get 10.6099. Last step, we always want to round to significant figures and add units. The given has 3 significant figures, so my answer has 3 significant figures, and my units are grams. Final answer, 10.6 grams of carbon. We're going to do 2 more problems, and these problems sometimes are tricky for students. And I'll show you why. What if you were asked how many oxygen atoms are in 1.5 moles of carbon dioxide? Here's why this problem is tricky. We're solving for just oxygen atoms, but you are given carbon dioxide. So what you have to know is that in every 1 mole of CO2, there is 1 mole of carbon, because carbon has that imaginary subscript of 1, and there are 2 oxygens. So hopefully that makes sense. For every 1 carbon dioxide, we have twice as many oxygens. This model represents carbon dioxide. So carbon is in the middle, and then the red atoms are oxygen. If I have 1 carbon dioxide, I have 2 oxygens, twice as many. If I have 2 carbon dioxides, I have 1, 2, 3, 4 oxygens. For every 1 carbon dioxide, I have twice as much oxygen. If I had 3 carbon dioxides, I have 1, 2, 3, 4, 5, 6 oxygens. For every 1 mole of carbon dioxide, you have twice as much oxygen. So how would we solve this problem? We're going to follow the same basic steps. Let's start with the given. My given is 1.5 moles of CO2. Again, we're still going to set up our units so they cancel. Moles will go in the denominator. And I'm solving for atoms. If I'm going from moles to atoms, I'm going to use Avogadro's number. So if we were to stop and solve, 1.5 times 6.022 E23, I get 9.033 times 10 to the 23rd carbon dioxide atoms. The reason this is not the right answer is because this is how many carbon dioxide atoms we have. I want to know how many oxygen atoms there are. Well, for every 1 mole of CO2, there are 2 moles of oxygen. So all you have to do is take your final answer and multiply it by 2. I have twice as much oxygen. So 1.8066 times 10 to the 24th. We always want to round, in this case, to significant figures. And then we need units. Let's try one more like this, and we're going to set it up like a 2-step conversion and just do the whole calculation together. How many moles of oxygen are in 50.0 grams of H2SO4? So there's a few things that we want to look at. I'm given grams and I'm solving for moles. So think about what your conversion factor would be. But then we also want to pay attention that we're given sulfuric acid, but we're only solving for oxygen. So let's start with the given. 50.0 grams H2SO4. First step, if we're going from grams to moles, is to plug in the molar mass, which is, this video is getting kind of long, 98.09 grams per every 1 mole. So now grams divided by grams are going to cancel. We can just make this into a 2-step problem. Both the unit and the substance cancels. So moles of H2SO4 will go in the denominator. And I'm solving for oxygen. So for every 1 sulfuric acid, I have 4 moles of oxygen. So now moles of H2SO4 will cancel. I'm going to be left with moles of oxygen, which is exactly what we're solving for. So just like in the last problem, there were 2 oxygens in carbon dioxide, so we multiplied our answer by 2. I have 4 oxygens in sulfuric acid, so we multiply our answer by 4. All right, we're going to multiply across the top and divide by the bottom. Last step is let's round the appropriate number of significant figures. 50.0 has 3 significant figures. So 2.04 moles.